Example 5. Let x represent the number of years since 2000. The function h of x equals 20x squared plus 16x plus 300 represents the population of bass in a small lake. In 2000, the lake had a population of 250 trout. The population of trout increased by 6% each year. Part A. From 2000 to 2010, which fish population had a greater rate of change? Now, I'm going to split our page. On the left, we're going to do our bass. On the right, we're going to do our trout. And we need to find from 2000 to 2010 the rate of change, which essentially means slope. And the way we find slope is we do y2 minus y1 over x2 minus x1 between 2 points. Now, if I'm dealing with my bass, I have this function up here that represents my population. So we're dealing with h of x equals 20x squared plus 16x plus 300. And we need 2 points to find the rate of change. Well, we're doing from 2000 to 2010. And x represents the amount of time since 2000. So my first point is going to be 0, comma something. This is in 2000. And then 10 years later, 10, comma something. So then the question is, well, if this is my bass population, what was my starting bass population in the year 2000? There's 2 ways you can find that. First of all, you can substitute in 0 for x. Or second of all, you can just look at your c value, which is your y-intercept. So I know this is going to be 300. Now, at this point, I have to find my bass population 10 years later. So I'm going to come up here, and I'm going to substitute in 10. So h of 10 equals 20 times 10 squared plus 16 times 10 plus 300. Now, you take a second, pause the video. I'll take a second. We have to substitute this into our calculators. So I've got 20 times 10 squared plus 16 times 10 plus 300, which gives me 2,460. Now, if I want to know the rate of change between those 2 points, we're going to do the change in y. So 2460 minus 300 over 10 minus 0, which gets me 2,160 over 10, which is 216 fish per year. Now we have to go do trout. So if we're doing trout, essentially we want to do the same thing. So I'm going to have 0, comma something, and then I'm going to have 10, comma something. Well, looking at the trout population, what was the initial trout population in the year 2000? Well, it says right here, 250. But what was the trout population 10 years later? Well, they don't tell me that, but they did tell me that the trout population increases by 6% each year. And if you're looking at 6%, I know that this is exponential. So 6%, y equals a times b to the x. Another formula you might remember from secondary 1 is y equals a times 1 plus r to the x power. That's exponential growth. R is your rate, and your rate here is 6%. But if you write that as a decimal, essentially you're going to divide by 100, which is 0.06. So we're going to have y equals, A is our starting amount. We started with 250 trout, times 1 plus our rate to the power of x, or t in this case. It doesn't really matter. And I want to know what it is 10 years later. So I'm going to use my formula. I'm going to do y equals 250 times 1.06 to the 10th power. Okay, you take a second, I'll take a second. Substitute that in our calculators. And I got 447.7, which I'm going to round to 448 because we're talking about fish and you really can't have 0.7 of a fish. Now at this point we have to find the rate of change. So slope 448 minus 250 over 10 minus 0. That's going to give us 198 over 10, which is 19.8, which again, I'm going to round that and say about 20 fish per year. Okay, so going back, part A said, which fish population had a greater rate of change? That's your bass. So ultimately, bass, because they're growing at 216 fish per year versus the trout are only growing at 20 fish per year. Now, part B, which species of fish will eventually have a greater population? And the key word here is eventually. Okay, right now, bass is growing faster, but bass is quadratic. Trout is exponential. And what we know is that exponential growth eventually exceeds all other growth. It's faster than linear, it's faster than quadratic. So eventually, which one's going to be faster? Trout. And the reason? Because exponential growth eventually exceeds all others. Okay, so if you go think about example 4 that we just did with the money, eventually you're going to have more money if it's growing exponentially versus linearly.